All right, so now we're going to take what we've learned over these past examples and see if we can apply it to more complicated binomials. But it just looks complicated, but when we kind of peel back all the fluffiness, then we'll find out, oh, okay, so it's either going to be our binomial squared or difference of squares or something like that. So check this out here. Okay, so when we look at this guy, we see that we have x minus y plus z times x minus y minus z. Okay, so basically, if you were to think of this as, if you were to imagine that this whole thing was just, let's call it A for now, and this whole thing was A, and I can call it both A because they're the exact same thing, right? So I'm going to say that A is x minus y and x minus y, then this is what this would look like. This is A plus z times A minus z. And what does that look like? That's right, a squared minus z squared, right? This is our difference of two squares, okay? And so basically the way that we solve this is you take our a term, you square it, you take our z term, you square it, and you put a minus sign, and then we're done. So let's do that then, right? So let's take our a term, or x minus y, square it, minus take our z term and square it. And there it is. Now, we don't want to leave it like this because we can still simplify this more by multiplying it out, but this was the tricky part about it, was just recognizing like, oh, look, this is a difference of two squares. Okay? The long way would have been to multiply, do FOIL, this times that, the first terms, the outside terms, the inside, and the last. That would have worked. It would have been, I think, more work. But so if I square this, now we're also going to use what we learned about binomial squares. If I have x minus y squared, remember that was the same thing as saying x squared minus 2xy plus y squared. We learned that from example number 6, right there. See, x minus y squared is x squared minus 2xy plus y squared. So that's all like I'm doing right now. So if I were to expand this, it would be actually just that right there. Like it's the rule. X squared minus 2xy plus y squared. And then we bring this down, minus z squared. And you can't combine anything together because there are two things that must happen to be true, is they must have the same base and the exact same exponent to combine. And that's not true there. All right, now this guy right here, this is the first time now we're seeing now a power of 3. So let's just expand this first. That's probably first a good idea here, possibly here. So we have a p plus 2q times a p plus 2q squared. Okay, so check this out. That's what I have right here. P plus 2q times p plus 2q squared. The reason why I did this was because I want to utilize our binomial squared, meaning if I use x plus y squared, that's the same thing as x squared plus 2xy plus y squared. We learned that from example number 6. So let's first do that. Let's just focus on this part right here first, and let's expand that using our binomial squared. So I take my first term, right, x, and I square it. So square p squared. Then I multiply these two terms, p times 2q. Well, that's 2pq. And then I multiply it by 2 again, right? It's 2 times the first times the last term. Okay, so it's 2 times the first term times the last term. Okay? Plus, it's the y term, or the last term squared. So here's my last term, 2q. Square 2 squared q, I get 4q squared. All right, now just combine those together, and I get p squared plus 2 times 2 is 4 pq plus 4q squared. Okay, so that takes care of this part, but that means we still have to multiply p plus 2q. All right, and this is where you have to get a little hairy now, but it's part of the whole gig here. So basically, I'm just going to take my first term, q or p, and I'm going to multiply p with everything. Multiply that by p, and that by p. And if I do that, I get p cubed. P times p squared is p cubed. P times 4pq is plus 4p squared q, right? Because p times p is p squared. And then I have my 4 and my q still. Plus p times 4q squared is just 4pq squared. Okay. Now let's go ahead and multiply now everything by 2q. And if anything matches any of this, meaning if it's a common term, I'm going to put it right underneath it. 2qp squared, well, there isn't anything that's going to match that right there, so I'm just going to put this over here. Plus 2p squared q. Oh, snaps, wait a minute. That actually matches right there. So let's just take that bad boy and put that right here. Oh, snaps. There we go. Right? Because 2qp squared is 2q squared p squared p. 2p squared q. Okay, I think I could do this. 2q times this guy is 8pq squared. And see how this right here would be right here. 8pq squared. And the reason why I'm lining these up is because they have the same base, p squared q, and the same exponent. If those are exactly the same, then we can combine those together. And then lastly, right here, plus, what's that going to give us? 4p, is it 4p q squared? I think that's all right. Oh, wait, for this last one right here, it would actually not be that. 2q times 4q squared, 2 times 4 is 8, and then q times q to the power of 2 is a q cubed. Q cubed. Wow, that's a lot right there. Okay, so now we can just go ahead and add down and see what we get here. So we have p cubed. We can add those down right there. We have 6p squared q. Here we have 12pq squared, and lastly 8q cubed. Whew, that one's a little hairy guy right there. Fantastic. All right, and going on now to letter C. Same thing, kind of thing. Where we're gonna be using the x plus y quantity squared, right? Which is the x squared plus 2xy plus y squared. So this is our binomial square. I'm going to use that twice here. So watch this. I'm going to break this down into x plus 2 squared times x plus 2 squared, right? Because this right here is equivalent to x plus 2 quantity to the power of 4, right? So let's do this part right here. And it doesn't matter. I mean, there's so many ways that you could break this up into 4 different binomials. It's up to you here. But this guy will just become x squared plus multiply these 2 times x and multiply that by 2, right? It's 2 times the first times the last term. So 2 times this is 2x times 2 again is 4x. And then 2 squared is 4. Okay, so this represents that, and we're going to do that again because that's exactly what that is. X squared plus 4x plus 4. Okay, great. And really, is there a cool shortcut? Not really, unless you're using some kind of computer system like Wolfram Alpha or something. You just plug it in and it'll do the whole thing for you. But here we're going to just multiply every term out. So I'm going to take x squared. I'm going to multiply it, and then multiply it. Okay. So x times x squared, x to the 4. X squared times 4x plus 4x cubed. And by the way, it's super simple or easy to make an error because there's so many signs and calculations. So It's always good to take your time on these guys. X squared times 4 plus 4x squared. Okay, now let's go with the 4x now. So 4x multiplied by 4x and multiplied by 4x. So 4x times x squared is 4x cubed. So I'm going to do it right below here. Plus 4x cubed. 4x times 4x is 16x squared. Notice that I'm lining these up because they have the same variable and base. 4x times 4 is plus 16x. Okay, and let's do the 4 now. 4 times x squared, 4 times 4x, and 4 times 4. 4 times x squared is 4x squared. 4 times 4x is 16x. And then 4 times 4. And now we can add all this together. Okay? So we get x to the power of 4 plus 8x cubed plus 1624, 24x squared. 15 is 32 more, so that's 32x and plus 16. And nothing can be combined together because, again, they don't have the same variable and exponent.